All right, taking a look at this ratio review. M1.28. There are 28 blue pencils, 42 yellow pencils, and 12 red pencils. What is the ratio of blue pencils to red pencils? Blue to red. So this information about yellow is just a distraction. And I have a set of 4 ratios that I need to pick from, and I am supposed to use a table of equivalent ratios. So I will have my blue to my red, and I know there are 28 blue and 12 red. First thing I'm going to do is scale this to have largest possible units. So I'm looking for the greatest common factor of 28 and 12. Largest number I can divide them both by, which is 4, which will give me a ratio of 7 to 3, which means 7 to 3 is equivalent to 28 to 12. This first answer choice here, 14 and 6, the 7, if I double the 7, that'll give me 14. Double the 3, that'll give me 6. So that one works. If I'm going to get 28, looking at this second ratio here, 7 times 4, oh, well goodness, I already have a 28 right here in the table, and it goes with a 12, so this is definitely not going to work. And I've already got 28 to 12, so 12 to 28, that's not going to work. I have more blue pencils than red pencils, so it doesn't really work to have less blue pencils than red pencils. All right, taking a look at number 2. In the parking lot, there are 5 minivans for every 7 passenger cars. If there are 28 passenger cars in the parking lot, how many minivans are in the parking lot? Find the solution by creating a table of equivalent ratios. So I'm going to have the minivans, and I'm going to have the cars. And it says there are 5 minivans for 7 passenger cars, and I need to scale up the passenger cars until I have 28 of them. So 7, 14, 21, and it looks like I'm going to run out of room here. I'll put in a 28. I'll count by 7s. So the minivans count by 5s, 5, 10, 15, 20. So if there are 28 passenger cars, there are 20 minivans. In the parking lot. All right, must be harvest season. Looking at potatoes and tomatoes. For every 12 potatoes, there are 9 tomatoes. Complete the table of equivalent ratios for the given situation. Write 2 equations showing the relationship between potatoes and tomatoes. And I know I'm saying those kind of funny, but hey, it is what it is. All right, so 12 potatoes, 9 tomatoes. And I'm on the side here going to scale this to largest possible units. I can divide both of these by 3, which will give me a ratio of 4 to 3, which should make it easier for me to complete this table. So 4 times 2 is 8, and 3 times 2 is 6. And 3 times 10 is 30, and 4 times 10 is 40. and 3 times 7 is 21, and 4 times 7 is 28. The table is complete. Now I need to write my equation showing the relationship between the two parts of the ratio, potatoes and tomatoes. So I'm going to start by writing that I am looking at the ratio of potatoes to tomatoes, which is 4 to 3, which if I turn into a ratio value so that I can perform operations is 4/3. The potatoes are 4/3 of the tomatoes. The potatoes are 4/3 of the tomatoes. For my other equation, I will write the ratio of tomatoes to potatoes, 3 to 4, with a value of 3/4. The tomatoes are 3/4 of the potatoes. So I've got my two equations showing the relationship between potatoes and tomatoes. A car travels 680 miles in 17 hours. This sounds like a rate question. How many minutes did the car travel? Ooh, I feel like this is a tricky question. When I first read it, I thought to myself, oh, I need to find out how many miles per hour they are traveling. But when I read the question carefully, what I see is I'm actually figuring out the total number of minutes that the car travels. So I need to take 17 hours and I need to turn it into minutes. This is just a distraction. So I'm going to start with hours and I want to end with minutes. I have my conversion rate here. I want to end with minutes. So minutes and hours. And this is multiplication because that's what we do with conversion rates. So I have 17 hours and I have 60 minutes and I have 1 hour. And remember, in the classroom on these questions, go ahead and pull out a calculator if you need it. 17 times 60 is 1,020 minutes. So in 17 hours there are 1,020 minutes. All right, one question to go. On Monday at 9 a.m. there are 54 cars waiting to be washed that day. At 1 p.m. there are 18 cars that still need to be washed. How many cars are being washed each hour? So I have two times here. I have 9 a.m. and I have 1 o'clock p.m. and I know there are 54 cars waiting at 9 o'clock, and I know that there are 18 waiting at 1 o'clock. So I can see that some cars have been washed. 54 minus 18. I can see that 36 cars have been washed. If I want to figure out how many cars are being washed each hour, I need to know how many hours it took to wash those 36 cars. So I've got 9 a.m., 10 a.m., 11 a.m., 12 noon, and 1 o'clock p.m. So I've got 1, 2, 3, 4 hours. They've cleaned 36 cars in 4 hours, which means they are cleaning 9 cars per hour. 9 cars per hour. Okay, 9 cars per hour. So if they continue washing at the same rate, how many hours will it take to wash the last 18 cars? Well, if we're doing 9 cars in 1 hour, and I want to get to 18 cars, I'll multiply times 2, and I will find that it will take 2 more hours to wash the last 2 cars. And the question doesn't ask me this, but what time are they going to finish? Well, if I take my 1 o'clock p.m., which I know is kind of off the recording here, and I add 2 hours, it'll be 3 o'clock p.m. that they will finish washing the cars. And that concludes this little walkthrough of the ratio review.